So this is part 3 of multiplying and dividing radicals, section 5.2, and we're going to take a look at dividing radicals. Two things to remember, just like with multiplication. When you want to divide radicals, you divide the coefficients and divide the radicands. Second thing to remember is you can only divide radicals that have the same index. Okay, so just a reminder that they don't have to be like radicals, they just have to share the same index. So our first illustration is 4 times the cube root of 6 divided by 2 times the cube root of 3. And I forgot to put the 3 here, so just put a cube root in there. Okay, so following the rule above, we want to divide our coefficients. So our coefficients are 4 and 2, and our radicands are 6 and 3. So if we write it out in a more longhand way, we would have 4 over 2, and then the cube root of 6 divided by 3. Okay, and so the 4 over 2 becomes the 2, and the cube root of 6 divided by 3 becomes the cube root of 2. So if we take a look at our explanation here, it says in general, m times the k root of a divided by n times the k root of b is the same thing as saying m over n, those are your coefficients, times k root of a divided by b, which are your radicands. So k is a natural number meaning 1, 2, 3, 4, and so on. M, N, A, and B are real numbers. And just a couple of things to discuss here. N can't be 0, and if you notice, N is in the denominator, and that's because we can't divide by 0. And the same thing is true for B. B can't be 0 because, once again, it's in the denominator and you can't divide by 0. So why can't you divide by 0? Well, one way to look at it is to write an equation like, here, let's start. We'll divide by 0. So we could say 12 divided by 0 should be equal to some number x. And if I multiply both sides by 0, I can simplify to that 12 is equal to 0x. But we know that doesn't work because 0 times a number is 0, not 12. Okay? Alright, so let's move on to our next topic, which is rationalizing a denominator. When we divide, we would be concerned about that, okay? Because no fractional expression is considered simplified if you have a radical in the denominator, so we want to rationalize. So before we do that, let's just talk about what an irrational number is, or review it. Okay, so an irrational number is any number that cannot be written in the form of a ratio a over b, where once again b can't be 0 because you can't divide by 0. Okay, an example would be like the square root of 2, because when we calculate that we get 1.41 with a series of numbers after it. And we can see, if our calculator screen was wider, we would have more numbers. So if we had that, we would see that this would be a non-terminating and non-repeating decimal. Okay, and that means it's irrational. So other examples would be like root 5, root 7, root 13, and so on. So to simplify an expression that has a radical in the denominator, you need to rationalize the denominator. So for an expression with a monomial, we'll look at that first. square root denominator, you want to multiply the numerator and the denominator by the radical term from the denominator. Okay, so if we take a look at the illustration that we have, we've got 5 divided by 2 root 3, and as you can see, the radical is root 3. And if we go back up here, the way we rationalize it is to multiply both the numerator and the denominator by root 3. Okay, and so we would have root 3 over root 3. Now, why can we do that? Well, if we take a look at root 3 divided by root 3, we know anything divided by itself is equal to 1. And because we're multiplying by 1, the value of the expression does not change. Okay? All right, and that's true. Anything times 1 is itself. So if I multiply 5 over 2 root 3 by root 3 over root 3, it's still the same value. Okay, so now you're going to multiply your numerator, so 5 times root 3 to give you 5 root 3, and then 2 root 3 times root 3 to give you 2 root 3 times root 3. Okay, so our numerator is 5 root 3. In the denominator, and I will do this over on the side, when you multiply 2 root 3 times root 3, that's really 2 times the square root of 9, right? Because root 3 times root 3 is root 9. And the square root of 9 is 3, so it's really 2 times 3, which is 6, which is why we have 6 in the denominator. Okay? And if you take a look, our denominator is now a rational number, not irrational. Okay, so off on the side here we have a little explanation here. To rationalize means to convert to a rational number without changing the value of the expression. And we don't change the value of the expression because we're multiplying by 1. If the radical is in the denominator, both the numerator and the denominator must be multiplied by a quantity that will produce a rational denominator. So we want to pick the rational number that's in the denominator. Okay, and in this case, root 3. So we're going to have root 3 over root 3. Now, as we discussed in class, if you forgot that you were going to multiply by root 3 over root 3, you could multiply by 2 root 3 over 2 root 3. It's still equal to 1. The only thing is in the end, you're going to have to do some kind of reducing. Okay, what if we don't have a monomial in the denominator? What if we have a binomial in our denominator? Well, then we have to know what's called a conjugate. Okay? And if you take a look over at the side, conjugates plural, okay, means we have 2 binomial factors whose product is the difference of 2 squares. Now, the only way to get the difference of 2 squares is if we multiply a sum and a difference. The binomials a plus b and a minus b are conjugates since their product is a squared minus b squared. Okay, and that's something that you learned last year in grade 10. So if we go over here, we've got a minus b times a plus b. These are conjugates. Okay, and if we FOIL it, all right, so let's just do that over here. If we FOIL it, we get a squared plus ab minus b squared. And notice that your middle term is going to give you 0, which is why you have a binomial a squared minus b squared. Okay, so a sum and difference will give you the difference of squares. Okay, now there is a shortcut to work this out, so let's take a look at if we have radicals. Okay, so here are our conjugates. Okay, one is a sum, one is a difference. Our shortcut is this. If I just square the first term, so the square root of u all squared, minus the square of the second term, our second term being square root of v, so root v squared, then I will come up with an answer. Okay, in this case, the square root of u squared is u, and the square root of v squared is v, and we have a difference. Okay, that's our difference. All right, and why does that work? Well, as you can tell up here, the middle terms will cancel. Okay, our last term is always going to be minus. Okay, and the reason for that is because you're going to go negative b times positive b to get negative b squared. You're going to go positive root v times negative root v, and you're going to get minus v. Okay, so it's always going to be a difference. Okay, so let's take a look at this example, okay, where you have 5 root 3 over 4 minus root 6. Now, the conjugate of 4 minus root 6 is 4 plus root 6 and negative 4 minus root 6. And we're just going to focus on this one. Okay, we won't take a look at the second one. Notice that they both share the same term, so 4 and 4, root 6 and root 6. One is minus and one is plus. Okay, so let's see if we can't figure out some other ones. Let's say you have root 3 plus 5. Okay, its conjugate is root 3 minus 5. Okay, let's say you have 2 root 7 minus 6. Then its conjugate is 2 root 2 plus 6. Okay, so notice that your conjugates just have to have opposite signs. They have exactly the same terms but opposite signs. Okay, so if we go over to our example, we have a denominator which is a binomial, 4 minus root 6. The conjugate is 4 plus root 6. We're going to times by 4 plus root 6 over 4 plus root 6. And just a reminder, that is multiplying by 1, right? Because anything divided by itself is 1, so we're not actually changing the value of it. Okay? Alright, so we're going to use the distributive principle to multiply the numerator. And you really should put the denominator in a bracket because you are going to actually be multiplying two binomials together. Okay? So we use our shortcut for the denominator, right? We're going to go first term 4 squared minus our second term root 6 squared. Our numerator, we're going to go 5 root 3 times 4 to get 20 root 3 and 5 root 3 times root 6 to get 5 root 18. Okay, so simplify what is in the numerator. 20 root 3 plus 5 root 18 becomes 20 root 3 plus 5 square root of 9 times 2, which simplifies to 20 root 3 plus 15 root 2. And when we simplify our denominator, 4 squared is 16. Root 6 times root 6 is 6. 16 minus 6 is 10. Okay, now to show you how you go from 20 root 3 plus 15 root 2 over 10 to 4 root 3 plus 3 root 2 over 2, we're going to go over here. And we take a look at all of our coefficients of our radicals plus our denominator. So we've got coefficients of 20 and 5. Oh, here, I'll do it down here, sorry. Okay. And we have a denominator of 10. Notice that you have a GCF of 5. So what we're going to do is we're going to factor out the 5 from the numerator, and we're going to be left with 4 root 3 plus 3 root 2 divided by 10, and then we will reduce. We're going to go 5 into 5 once, 5 into 10 2 times, and that's why you get 4 root 3 plus 3 root 2 over 2. Now, don't get confused. If we came up with an expression like 20 root 3 plus 19 root 2 over 10, okay, take a look at your coefficients here and your denominator. You don't have a GCF for all three terms. So it's not correct then to just reduce the 20 and the 10. You need to have a common factor from both terms in the numerator before you can reduce with the 10. Okay? So you don't go, 10 into 20 is 2 times. You don't get this for an answer. Okay, that's not right. Okay, this is how you leave it. This is as simplified as it will get.